On behalf of the Bridge to a Cure Foundation and all the children that are fighting cancer, and on behalf of Pam and myself, thank you so much for being here. I mean, we thank you big time. Your support and encouragement over the years has been just wonderful. And it's made a difference on our performance, and hopefully you'll see that throughout the presentations today. Hi, Adam. Thanks for joining us. He's the executive director of the Children's Brain Tumor Network. And he's been engaged with the National Institute of Health, which we call NIH, you'll hear that acronym, and the National Cancer Institute, NCI, when it comes to childhood brain tumor data collection, sharing, collaboration, tools, research, technology. He's the go-to person. He's the person that started this change that's going to revolutionize pediatric cancer brain tumor research. An amazing man, and he'll be available for questions as we go through the presentations and at the end of the presentations. I'd also like to introduce, some of you know Wendy Payton. Wendy, please stand up. Wendy used to be our executive director, but as part of our transition into the Children's Brain Tumor Network, where we align our resources together, she's now an executive with the Children's Brain Tumor Network. But she's also now on the board of the Bridge to a Cure Foundation. So it's a great marriage, and it's working extremely well. I also, last year, I made a presentation. I went through our board of directors, and just to give you some information about each one. Because I wanted you to have a sense of how the influence that our foundation is receiving because of people that are so well positioned and key influences in the U.S. today. And I'm pleased to introduce you to one of our first board of advisors, Lois Juleber. Lois, would you please stand for a second? Yeah. Lois has been kind of involved with my family for many, many, many years. And she brings with her an incredible experience on corporate boards, some of which you probably know. State Street, DuPont, Goldman Sachs, Kraft, Mondelez, Corteva. On the tables, you'll see handouts of our annual report and something called a one sheet. And the one sheet we hope you will take with you when you meet with friends and you want to talk about the Bridge to a Cure. This gives a quick overview of what we're all about. So hopefully you'll put that to good use. Also, there's a Super Clara book and waffles, just so you get a sense of that. We give those to the hospitals, children's hospitals. To wear is a Bridge to a Cure hat. That's our logo on the hat. And as you wear it, people say, boy, what is that magnificent hat? You can tell them about Bridge to a Cure. This is what we hope are the takeaways. First, that the approach to pediatric cancer research has been flawed. Second, that there is a solution, and it's pretty simple. Get the right data in the right hands with the right technology. The problem is the execution of that simple solution is anything but simple. And the fourth thing we hope you walk away with is the organization of Bridge to a Cure and the Children's Brain Tumor Network. They're best positioned to make this happen. If anyone's going to implement this solution, we're the ones that are going to do it, and you'll understand why. And we'll revisit this at the end of the presentation to see if we delivered on our promise. So here's the agenda. Go through some background. Our journey, everything from the time that our granddaughter Clara was diagnosed to how we developed the Bridge to a Cure Foundation and our mission. We built a lot of momentum. We want you to understand what that momentum is. We've led changes in government legislation. We've increased collaboration and significant increases in funding, government funding. Transformational research is really what we're all about and what we're driving. And much of that comes from Dr. Adam Resnick. And you'll learn more about why, how this is going to lead to cures and where we are in the process of making that happen. And finally, at the end, we'll do a wrap-up, first to see if we delivered on our promise in terms of the takeaways, but it'll open up to questions. It's rare that we can have the opportunity to have Dr. Resnick with us, and he'd be welcome any questions that you may have about what we are up to looking for a cure for pediatric brain tumors. So in terms of background, three pieces to that. Our reason for being Basically, this deals with the diagnosis of our granddaughter Clara, our findings, what we learned during the journey as we looked for a cure, and then finally we'll share with you our mission and our strategies. And we do this because it's important that we understand where we started and to where we are now, to really measure the progress that we've made. So in terms of our reason for being, on St. Patrick's Day of 2016, our granddaughter Clara was diagnosed with a brain tumor, age 4. I spent every waking hour searching the globe for a cure. I've met with over 130 practitioners, pediatric cancer practitioners, 7 countries, explored over 100 possible treatments. I even packed my bags and went to Lourdes and brought back holy water. Sadly, none of this worked, and she passed on October 8th of 2017. My findings during this journey not only made me quite angry, but I was surprised. You know, cancer was the #1 killer of children in the United States. In fact, brain tumors are the #1 killer in the United States. Over the past 40 years, no cures have been developed for brain tumors. For many cancers, the treatments that they use today for pediatric cancers is the same treatment they used in the 1970s. Unacceptable. They have a low bar for success. They consider if a child survives 5 years, that's survival. Well, damn, that's not right. That just isn't right. The journey is also horrific. There's severe chronic pain for each child that has to deal with this, harmful emotional strain, occupational disruption, financial hits, and long, ongoing, deep psychological damage. And coming back to those that do suffer, that do survive, 95% of those children that survive have significant health-related issues later in life, 95%. And the emotional strain continues, as does the recovery of the financial challenges. So there's a couple of things that drive us. As horrific as Clara's journey was, she never lost hope. She was always upbeat, was always more worried about our happiness than her own struggle. In fact, there's a book on the table. Her older sister, Kira, and I wrote a book to honor her courage. And while Clara's hope was never fulfilled, she would have been disappointed if I didn't continue to search for a cure for other children with cancer. This is what inspires us at Bridge to a Cure every day. The combination of those things is what has led us to the beginning of the Bridge to a Cure Foundation and our mission to unite and transform the childhood cancer community's approach to research with the goal to cut childhood cancer deaths 50% by 2030. Our focus is on childhood brain tumors because they're the #1 killer of children. And if we cure brain tumors, we achieve our goal. That's how important brain tumors are in us reaching our goal. And just another side comment. You'll hear more about this later. The model that we've created, the right data in the right hands with the right technology, can be applied to any children's disease. And we're way ahead of the game than anybody else. But I just think about the potential for those families that have children with other types of disease or mental disorders. I mean, it's really going to be enormous. And you'll hear more about that from Dr. Resnick during the wrap-up. So the next part was we're building momentum, a lot of momentum. On October 5th of 2017, 3 days before Clara passed, I met with the director of the National Cancer Institute. And I made a presentation to him on a framework for a database and how important it was to use artificial intelligence and data to find cures. He took that and developed it in what now has become our National Children's Cancer Data Initiative. $500 million the government is investing over 10 years, $50 million a year. So we came out of the gate with a big success. But our momentum continues to build. Recent legislation enacted. Now, pharmaceutical companies that create a drug for adults, because that's where the profit is for cancer, they're now required to take that knowledge and begin working on a cure for children. It's not that simple, because the biology and pathology of a child is very different from an adult, and so are the cancers. However, at least we have them in the game. We're getting some of their funds to look for cures. We also have new legislation for brain tumors that requires brain tumor researchers, if they want a grant from the National Cancer Institute or the National Institute of Health, they have to agree that they're going to share all of their data. No more just keeping it within their institution. It's got to be open to everyone. And then finally, in terms of the government investing in pediatric cancer, we've gone from 4% to 8%. We've doubled the amount of money that our government is investing in pediatric cancer. In terms of data collection, we now have millions of data points. It's extraordinary. We have 8,000 complete data sets. And understanding data sets is a little bit complicated. That's why Wendy's going to handle that part of it. But there's a lot that goes into data, more than you might imagine. In terms of technology, we have a number of tech partners, but today we're going to talk about perhaps our most important one, Amazon. They came to us because of the work of the Children's Brain Tumor Network. We have so much data, and it's the right data in the right place. And we'll be talking about some of the initiatives that we've started with Amazon. So now we're going to talk a bit about transformational research. This is really where we get the best technology with the right technology with the right people, the right data with the right people and the right technology. And our relationship with CBTN is so important to all of this. We began that relationship a little over 3 years ago with the Children's Brain Tumor Network. It became clear to me that their mission and strategic imperatives were actually fully aligned with what we were trying to do. And given the size of that organization, the resources that they have, researchers, clinicians, patients, other foundations that are linked into them now, 35 institutions around the world that are linked in with them. It made more sense for us to begin to integrate into their organization. CBTN, instead of Children's Brain Tumor Network, it's a lot easier to use CBTN, has been cited by the National Cancer Institute as the model for data collection, access, and analysis. They are the lead in this arena, by far. No one else is close to them. And today I wanted to connect you with Adam and Children's Brain Tumor Cancer Initiative. As I said, they are the model that we all need to follow for all diseases. I'd like to share a short video that talks about our relationship together.
In 2017, Bob Martin established the Bridge to a Cure Foundation to forge a collaborative model for data sharing in pediatric cancer research. His mission is to transform the research community to reduce childhood cancer deaths 50% by 2030. It starts with brain tumors, a type of which claimed the life of his beloved 6-year-old granddaughter, Clara, who never gave up in her courageous fight.
We've become a leader, if not the leader, as a foundation in brain tumor cancer research in terms of funding, and not just funding, but providing strategies for organizations that are actually doing the research. One of those organizations is the Children's Brain Tumor Network.
The Children's Brain Tumor Network, or CBTN, is transforming childhood brain tumor research by creating the first ever globally accessible research resources that were never available before. Today, there are over 34 research institutions and over 1,000 researchers tapping into CBTN's pediatric brain tumor database.
So researchers that were even interested in doing pediatric brain tumor research had to start from scratch, and it would take normally up to 5 to 10 years before they could even begin their project. Today, CBTN has those resources available, and they can start that same day.
Bob's vision has for years run parallel to CBTN's. In fact, he serves on CBTN's executive board and meets regularly with CBTN leadership to assess progress and provide strategic guidance.
The Children's Brain Tumor Network is a rock star. They are by far the lead organization for data collection and making that data available to scientists and researchers around the world.
What does this strategic alliance mean for your generous support of Bridge to a Cure? First and foremost, exponential impact. Your support will help Bridge to a Cure extend its impact as a leader in advancing the work of CBTN's global network.
Together, we've had a large impact. And that relationship's only going to get stronger as time goes by. And I'm looking forward to those that support Bridge to a Cure today will continue to support us, maybe in a bigger way, as we build our relations with the Children's Brain Tumor Network.
Bridge to the Cure has been so transformational as part of the CBTN foundational model. Bridge to the Cure early on identified that these siloed-based mechanisms were not going to accelerate cures at the pace that was needed. So having the leadership from Bob to identify the same core issues that we did, but then align our resources and expertise was foundational to move this very simple collaborative model forward.
Clara never gave up, and neither will we. Now, more than ever, we need your continued support in our work to save children's lives. Together, we can all defeat this devastating disease.
Now I'd like to introduce Wendy, who will take us to the next part, talking more about the Children's Brain Tumor Network and the progress we're making there. Thanks, Wendy.
Well, you've heard a lot about the Children's Brain Tumor Network now. I've been with the inside of the Children's Brain Tumor Network for about 6 months now, and I am amazed every day at the work that's being done on behalf of patients, these kids and their families. It's amazing. And we're really a collaborative research effort that optimizes and shares data so that we can discover more effective treatments for childhood brain tumors. So our mission is twofold, and this is why we rarely sleep, because our vision requires success both in the near term and over the long haul. We need to advance personalized medicine for patients today. We need to get better at that. It's in its infancy, and we are on the leading edge. We also need to accelerate research so that we end childhood brain tumors forever. And as Bob's already mentioned, we can take this model and we can move it into other rare disease area for children. This slide shows you our network. It's a really great visual. Bob mentioned 35 member institutions across Europe, Asia, Australia, and the United States, and that's because today we just worked on a press release to announce that the Children's Hospital of Atlanta has joined us, and we're so excited about that. But if you consider that we had just 4 institutions around our banner in 2011, and now there are 35, we've doubled participation just since Bridge to a Cure has joined the network. And we're tearing down those silos and we're building those bridges that connect thousands of patient families, physicians, and researchers into this network. So I kind of liken data plus technology plus collaboration, and I'm in marketing, so I think of that in terms of a great slogan for maybe a telephone company or something. We don't even think about it. It's second nature to consumers. However, for many reasons, in medicine, this formula is virtually unheard of. We house the largest tissue biobank of its kind in the world. And we're different because we've removed all the barriers that limit progress to this disease. We do that in terms of freely sharing the data that we have. We have a magnitude of data available right now for free to scientists worldwide. We also have technology that's unparalleled. We have 5 robust cloud-based apps for scientific research and analysis that we maintain. We work with people like the NIH to make sure it's properly funded and that it is working on the leading edge. In fact, we have been hailed, CBTN has been hailed as the collaborative model and as the standard for meaningful research in rare pediatric disease space. These diseases are very complex, so no one researcher or institution is ever going to make the progress that our children desperately need. And you know how we know that? Because that's how we've been operating for 50 years, and we've seen nothing that has been produced for these children that will save their lives. Brain tumors are considered a rare disease for children. They are the #1 killer of kids by disease. And so we do need to pay attention, and it is important. The solution, that formula, right? That slogan, that was so simple. It is not easy to execute. It is very complicated. We have a very complicated mission in front of us. First of all, the disease. There are 125 types or subtypes of childhood brain tumors. It's so rare that a single hospital may only see a single case or two in a given year. No one institution can collect enough biospecimens, collect enough data to make meaningful research. It's also important to note that the blood-brain barrier, just the physiology of where this cancer is, makes it very difficult and very complex to treat. But you know, sharing is also difficult. And we don't have to go back to preschool to remember that. Our files are stored differently. Each institution has its own method, its own terminology. And so the transfer of that data too can be really arduous. And it can take months. Security is a big issue. And if there are any attorneys in the room, you know that it can take multiple years to create agreements between different institutions in order to share and to make sure that patients are protected. One of the things that I thought was really interesting was that knowledge. It's difficult. People aren't teaching this in school. When you're a doctor, you don't get a course on how to use data and how to use these tech tools. It's surprising, but we've got to go in and develop all of this curriculum and teach these folks to use the data that's there. And then technology. Obviously, we've come a long way with technology, but we are just in the infancy of AI and cloud computing, and we are truly pioneers in this space. It's hard work, but we are really up to the task. And the reason we are is because we know it works. The traditional model, where you have one research team and one researcher addressing one question, cannot compete with our model, where we have hundreds working simultaneously using this foundational data in order to answer these questions that we need to solve. CBTN models updates, we have nearly now 7,000 participants. I don't know if you saw, but Bridge to a Cure recently put out a blog article about reaching 5,000 enrollees. So 5,000 children who believe strongly enough in what CBTN is doing to be enrolled. We have 340 research projects going on right now around the world. We already have shared consents and agreements in place, so these 35 institutions can all share and talk to each other. That is a breakthrough in and of itself. For the CBTN model, it's not siloed. It's all the shared data on cloud-based platforms available today. It's not one data type. It's data sets with different types of data that researchers can consider all at once. And it's not about sequestering results so somebody can publish and get ahead. With CBTN, this foundational data is shared globally. And so here's an example of what do we mean by accelerating. This is one example. Because we have the data collected and available on demand, it can save researchers, and it saved this researcher 8 years. 8 years of having to collect that on their own. That's the power of CBTN. We have a case that saved 20 years of research for a rare cancer. We have got to be doing this. These are kids. This is 2 generations of kids that we can save. And that's what the numbers mean to me. The difference? The data. So when we talk about this data, what do we mean? Well, data isn't just one type of information. There are lots of different sources. If you think about even when you go to the doctor and you see all of the blood work, and you may get imaging scans, you may have a lot of different types of tests, DNA tests. So all of that is a different piece of data, and there are lots of different sources for that. So it really is hard to collect all in one place. But it does give us the fullest picture of a patient that we can have over time to help us understand their biology and also that specific iteration of the disease. So our goal is so that when we better understand the disease, we can develop more effective treatments down to the child. So we are set up for multimodal research, and now we can start applying the technology that's becoming available, and you'll start hearing more about individualized medicine, and that's what we're supporting through this rich data. So our goal is to have a complete data set for every subject, each patient, all along their journey. So as their tumor changes, we can understand it better. But our challenge is that this has never been attempted before. Insurance covers pathology scans and imaging, but not all of it. And CBTN has been working and piecing it together manually ourselves because it's so important. There is not enough analysis right now to show that all patients need it, but we are conducting a pilot study to show how treatment will change with this information. And getting covered for kids is harder than getting covered for adults, so we're starting it in the adult population. We are also moving to leverage big data. We talk about all of the data sets that we have. It's really great because it can inform treatment. Generative AI models, they learn patterns and structure from the data that's input, and they train on that, and they are able to then begin generating new data to show similar patterns and characteristics so that we can start to leverage these rich data sets. We can look at what that allows us to do is look at that past experience for genomically similar patients and to start informing care for the person in front of them today, the child in front of them. We're piloting this at the Children's Hospital of Philadelphia, which is our operations center, and at other major treatment centers. Pharma companies are really excited about this and are really getting behind us because they're required, as Bob mentioned, to start funding and looking at childhood versions of some of these diseases. We can also create control arms with this data. And one of the things that is just heartbreaking is to think about a child being given a placebo or being given a standard of care that we know will not help them. With this data, we can look at the data and show what the treatment would be without having to harm children. We can put them in the test group. And obviously, it'll be safer for them, and we can move medicine to the market faster that way. So why did AWS, Amazon Web Service, why did they come to CBTN? They had a lot of options when it came to technology and data in the medical sector. It's because we are ready to move. We have teams already in place. We have experts on AI, on medicine, on ethics, and in regulatory fields already in place. We also have domain expertise. We have AI experts and medical professionals that ensure models are clinically relevant and accurate. We're ready to go. Gives us a big advantage. And all of this data that we've talked about, it's prepared and it's accessible. We've already done a tremendous amount of effort and work to get it ready for AI use. So we asked ourselves the question, can AI really improve care and outcomes for children? Well, we have some exciting news. In an initial study, we have found we can use AI successfully. Radiologists traditionally take two-dimensional measurements of tumors, and there's variance across professionals. I know even between my husband and I, when we go to measure something, we don't have the same answer a lot of times. So if you can imagine across the field, we may not have accurate measurements. It's really hard to measure a three-dimensional object in 2 dimensions. And there's no guarantee that the same radiologist is reviewing that patient scan every time. So the consistency is concerning. But could there be an automated way to do this, and would it make a difference? So we've taught AI to monitor tumor response and treatment and progression. AI allows us to observe things that the human eye can't see, and the first step is asking the right questions. So the team at CBTN trained AI to understand tumor growth and progression. And patients have MRI scans at regular intervals in their journey. What happened was we were able to segment the tumor to improve these measurements. We drew them on 244 subjects. We fed this information into an AI algorithm, and now the algorithm can take new MRIs and generate 3D segmentations automatically. Our initial outcome proved effective in capturing tumor progression earlier than the traditional method in more than half the cases. And when you're dealing with a disease as serious as this, being able to immediately react and treat could be life-saving. So the answer to our question is yes, but we have to continue this work. We need to expand the model. We need to translate this model into clinical trials and ultimately apply this model in clinical care. In no way have we arrived. There's so much more for us to do. We need to round out the data that we have. We may have one type of data but not the other. We want to make sure that we have complete sets for each and every patient so that the clinician, the doctor that's working on the patient, and the researcher that's studying has the best chance to provide the answers that we need for these children. We need to have perspective collection and data generation. So maybe we have a period in time with an initial diagnosis. Our goal is to collect all through that patient's journey. We need to work to structure the data for AI, and that is, again, not simple at all. It requires a team of engineers that will keep working on it and keep smoothing out this process. We need support for researchers so that they can ask the questions that are going to lead to the discoveries we need. And we need to engage with these researchers to train them and to use the data. Last month, I talked to a professor at the University of Louisville who wants to bring CBTN into the classroom so that he can train his students to use the data to answer their questions scientifically. And we need to establish a process for support and a process for precision medicine so that we can develop specific immunotherapies for each individual child. So what's new and on the horizon? Well, I think Adam is probably the best person to answer that, so let me turn it back over to Bob.
So we can open it up to questions. I have a question, though, for Adam. What's your vision for CBTN, and how will it help drive personalized medicine and cures for children with a brain tumor?
Sure, and for me, when I really appreciate the accolades, but as you guys heard from Wendy, this is really a team effort, a multi-institutional effort that requires really tremendous collaboration to get to where we are today. And I wish I was there in person. I actually grew up about a few hours north of where you guys are, in Brooksville, Florida. I went to high school there, then ultimately I went to college at UF before going to Hopkins. And I was trying to think of ways to, not knowing which question you're going to ask, Bob, but of ways to actually communicate and build on the narrative that Wendy shared with you. And I don't know, is there a screen that people can see?
Yes.
Can you guys see me? Okay, here. So, and so I only put 2 slides together just to highlight this, for let me see if I can share. We hear a lot about AI and the power of data. And as Wendy mentioned, key for this is having these large-scale multimodal data. And I've been trying to think of analogies for the future of precision medicine and where we're trying to head. And I realize that sort of anybody who lives in Florida is familiar with what officially is called spaghetti maps. This is that bottom left-hand corner where, essentially, every hurricane season, you'll see this on the news at one point in time or another. You'll hear about the European model or the US model. You'll try to sort of guess, like, where's the hurricane going to end up? And what you can see, right, is that, if you just try to predict one day ahead, you can be pretty certain where it is. 5 days ahead, it's a little bit harder to predict, and the cone of prediction widens. But the amazing part is that you can predict. And, I was thinking about this, how does this happen? And this happens because, you have airplanes flying into the hurricane and taking measurements. You have satellites, taking and capturing images across time, for these hurricanes. You have both land features and temperature, humidity, and all these other multimodal data and variables coming together. And they're largely, aggregated in real time. They're computed and analyzed in real time, compared against historical data and understanding to create this trajectory. And wouldn't it be amazing if actually we could do this for patients? And the reality is that we can, if we actually just follow the same recipe that Wendy highlighted. And as Wendy highlighted, we don't think about healthcare in the same way, but we can. And the exciting part is that the technology that's been empowering weather prediction, and actually by and large, in the weather context, everybody shares data in real time. There's no embargoes on data, right? Everybody expects to see their weather in the next minute, in the next hour, tomorrow, right? Nobody has like unavailability of weather prediction. That's the same sort of model we imagine. And I was reading, just this last week, that even in weather prediction, right, we are seeing this tremendous technology shift. So these are a series of articles, you might have heard about it in NPR or your local newspaper, that even in as established a framework as weather prediction, there's always room for improvement that is data-driven. And so this past week, and there was a lot of coverage of Google's advances in weather prediction using these new machine learning algorithms that can now essentially perform like these 10-day forecasts in under a minute on a laptop, right? So suddenly, even the technology that used to be required to analyze these big data frameworks, and we have more than 3 petabytes of data, for example, on CBTN, are improving at such a pace that you can actually analyze all this data on your laptop. And so it's really this unique combination of multidimensional data that's measuring as much of a current state or feature space of a disease, paired with this analytics, empowered as an open and discoverable framework. And so, for example, in this context here, Google is making all of its AI algorithms available for free and online, and constantly applying this technology in order to do what? In order to accelerate the process of interpretation and action in response to this data. And I think that's the approach that we're trying to advocate in the context of CBTN. And in many ways, cancer overall is a challenge for humanity. But in the pediatric context, and especially for brain tumors, out of existential need, we've had to figure out how to connect as a network, connect across hospitals, connect across resource to build this network framework that now is a substrate for innovation in ways that I think could parallel sort of weather forecasting, hopefully, where we can actually provide that spaghetti map of prediction for patients, and hopefully in contrast to weather, or hurricanes can actually do something about it. So, I'm thrilled that you guys joined there. I wish I could be there. My son is coming for the first time home from college today. I have to make sure he looks reasonable and survived his first semester at college. Otherwise, I would have been there visiting with you. But But Bridge to a Cure has been foundational in achieving this model that we're proposing. And Bob has been one of the very few who from the get-go saw and shared that same vision of a real-time data analytic framework that overturns essentially the current status quo of patients and their families not knowing, searching for answers in the way that Bob and his family did. So I appreciate you and your commitment, and Bob, I especially appreciate what you and Bridge to a Cure have done. And apologies if I went off script. Again, when I realized you guys were, were in Florida, I thought I'd align at least a mental model that at least I have of what we're trying to do and share it with you.
Well, thanks so much, Adam. Hey, we'll take some questions now. Any questions from the floor? For me or Wendy or Adam? How do brain tumors in children develop? Is it from birth? Or is it exposure to something? Or is it genetic? What would be the main reason?
So in reality, the answer is we don't fully know. We do know it's not because they smoke or out in the sun too much or eat poorly, right? It's not for the same reason that you or I or anybody else might get cancer. What we do know is that some of it, some cancers and some brain tumors are associated with an inheritance of a particular mutation by chance, but those are going to be a minority. What we think happens is that by chance, during development, as a cell divides, each time that a cell divides, it has to copy the entire 3 billion letters of the genome, and by chance, mistakes happen. In fact, all of us have mistakes in our genome compared to the genome of a parent. I think all of us know that we inherit one copy of a gene from your mother and one copy of a gene from your father. But all of us have probably tens to hundreds of mutations that happen just by chance, as DNA is copied when you are initially developing as an embryo. So for cancer, what we think happens is that just by chance, a mutation occurs in just the wrong gene at just the wrong time, at just the wrong cell during development in ways that cancer essentially originates and harnesses that development framework of childhood to expand and grow. So for example, we all know that children themselves, right, are rapidly dividing, growing being. Your brain grows at an astronomical rate for the first 29 years. After 29 years, your brain starts to shrink. So I only see a portion of the audience, but that portion of the audience shares that feature with me, which means that on a daily basis, we are losing brain cells in contrast to the first 29 years of our life. But it's during that developmental framework that essentially a mistake happens. And a mutation at just the wrong moment happens in ways that unleashes a series of events to drive the brain tumor process. We don't know why exactly that happens, but that's the best knowledge we currently have about the current setting for this.
Thank you, Adam. Other questions? Bill?
I think the question was, what's the number one challenge for sharing data? Correct me if I'm wrong.
Yes.
Yeah.
That's the question.
Yeah, so I don't think there's a single reason. I think I'll give you a set of reasons that collaborate to make this challenging. The first one is that even though academics and academic research is an egalitarian venture, each institution and each investigator's livelihood, by and large, is dependent on making discoveries and competing for funding from the National Institute of Health. Competition is great in many contexts, but inadvertently, competition can also hamper research, because you can imagine if you, as an investigator, are trying to make a discovery so you can get your funding, so you can get tenure, and you can remain at your prestigious institution, there might be disincentives to provide that data to another investigator who may make that discovery faster than you and get funding before you, right? This is where there's a misalignment in incentives and infrastructure, because really what we want to do is make sure that whoever can make the discovery fastest can make the discovery. I guarantee you no mom or dad cares who makes the discovery, right, on behalf of the next cure. But the incentive structure around research, when there is limited funding from the National Institute of Health, creates that barrier initially. The second one is that it actually, and as Wendy highlighted, takes effort to share data. Takes efforts to structure it, to provide it meaningfully, to make sure it makes sense, to put it in a place where somebody can access it, to support it, and its use. That infrastructure historically has not been supported on behalf of pediatric cancers or pediatric brain tumors in ways that we as a community had to build on our own. We take for granted accessibility to data and knowledge right now as humans. We can all log onto the web and find things out. But if you dig into it, you'll realize that anything that you access online has an incentive structure around it, whether it's because there are advertisements there, so they're making money through the advertising, or there's a product that's behind it. To do this for free, right, to advance access to data for free is challenging. And so that's the second layer, is that there was not funding or support for even researchers who wanted to share data to share that data. And then the last piece is that the incentive structures for drug development only until recently were not such that commercial enterprise was interested in that data. Big pharma was not so interested in developing drugs for smaller population. It would much rather develop drugs for prostate or breast or lung cancer. So they lack that additional commercialization incentive alongside the academic disincentives. And those combination of challenges initially hampered our community's success.
Well, let me move over to the wrap-up. So this is what we promised, that you would have an appreciation and your takeaways, that the approach to pediatric cancer research has been flawed. I hope we made that point clear. The solution is simple: the right data in the right hands with the right technology. However, the execution of that is not simple at all. And then finally, the organization's best position to make it happen is Bridge to a Cure and the Children's Brain Tumor Network. Do I have agreement from everyone that that's you buy into that? So, there's two parts to foundations that are really successful. One is they have an audacious goal, and I think finding a cure to pediatric brain tumors is a pretty audacious goal. The second is that they have the passion and the commitment to make it happen. And I'd like to share this video, which I think captures that.
What have we done? In the last half century, we've traveled to the stars, set foot on the moon. We've seen advancements change the course of humankind. We've made the impossible possible.
But when it comes to childhood cancer, in that same time, we have only developed a handful of treatments. Just 4 since 1980. 4. No cure, nothing even close.
But the problem isn't that we failed. It's that decades into this exhausting, excruciating fight, we've barely even gotten started.
We are done waiting. We are done staring into the faces of sick children and shattered parents. We are done. Today is the deadline, not tomorrow.
Today, we are building a database that can be accessed by scientists around the country. Today, we are gathering and sharing resources researchers have been desperate for. Today, we are developing a clinical trial process designed specifically for children, not just their cancer. Today, we are saying no more.
And until childhood cancer no longer robs a child of their future and a family of its heart, we will not stop. We can't. We mustn't. We won't. So, what have we done?
We've had enough.
So on behalf of the children and families everywhere affected by a brain tumor, I can't thank you all enough for your support. Thank you.
Thanks so much.